Let's go ahead and so now what we are doing is we are doing rpart.rules. So what does this function help us? So it tells what are the rules that have been taken to split our data. So here 0.12, it is telling you about the two nodes here, that is node 2 and node 3. So node 2 wherein the AM type 0.12, which is the manual type, when MPG is less than 19, and 73% cars when MPG is greater than 19. So they are the rules that our decision tree followed. If you do cover equal to true, what it will do is it will give you the percentage of the population taken for this rule. So 53% population has been covered in second node, and 47% of the population has been covered in third node. Now what we are doing is we are splitting our data, and then we will predict our data from that. So we have created a model to predict values. Now what we are doing is we are using sample n, wherein some of the rows, like I have mentioned 3 here, so 3 rows of this data set df will be uh, taken and will be saved in this variable sample1. So you can see 3 random observations has been taken and saved in a sample set. Now let's predict our values. For that, the formula is rpart.predict within the brackets. So rpart we are using for specifying it that it is for decision tree. So rpart.predict within the bracket your model variable, the variable containing your model, then the new data that we created just now, sample one, and rules equal to true. So the outcome will be like it will be telling you whether the car is what is the ratio of the cars, whether it is automatic or true. So there are 88% chances it is automatic. So our first data set was this. The first row of our data set was wherein the MPG is 18.7. So the rule followed is MPG less than 19. So if MPG is less than 19, you can guess it from the graph also. If MPG is less than 19, there is 88% chance that it is automatic, and 12% chance that it is manual. So it is telling you the same thing here. Next, our MPG was 19.2. So 19.2 is greater than 19 here. So and the 88% chance is it is automatic, and 12% chance it is manual. Then the MPG value is greater than 19, it is 21.4. So it is 26% chance or 27% chance, you can say, that it is automatic. Otherwise 70% chances that it is manual. So this is how you predict your data from decision tree. Let's take one more data set, that is Titanic data set. If you want to check this data set, let's check the first 6 rows. So you can see there are 1309 observations and 6 variables: P class, survived, sex, age, siblings or spouse, parents or children. So it is telling you about the class in which the passenger was, whether they survived or died, what was the sex of that person, what was the age, and how many siblings or spouse they had, or number of parents or children. So let's go ahead and create a data frame for it. So we will go 2 ways. First, we are creating model with the entire data set here. Next, what we will be doing, we will be splitting the data and then creating a new model, and we will be pruning the tree and we will be shortening our data. Let's execute the rpart model here, rpart. So we will be predicting whether the person died or survived based upon all the data, the variables available with us, except so the dot here, it helps us to take all the relevant variables present in that data set, then comma, name of the data set. It is DT2 in which our model is saved. So you can see it is a large model. And if you make this model, so CEX will increase the font size. So you can see it is a very big tree that we have just created using rpart.plot. So what we will be doing is we will be pruning this data and will be first partishing the data, then we will be pruning it. So first, to prune this data set, so if you want to understand how this data set is created, so it is saying it has covered, this is the root node here, which takes 100% of the population. You can, and let's compare here. So the root node covered all the observations, that is 1309 observations, out of which 500 is a loss, which means 500 survived, and majority of the data set tells the people here died, and the ratio is that is 61% they died in the Titanic, and 38% else they survived. Next, there is a first split based upon sex. So if it is male, if the person was male, so it is yes. So then there is next split. You can see here. Then the next split is based on age. Okay, if the sex was male, so percentage of died, how much it become? Majority people died, that is 80%, 81% died and 19% survived. Then there is next split here. If there was siblings greater than equal to 3, then there is chances of survival is, you can see, if the age is greater than 9. Okay, the first split was of sex, then it was based upon age. So if age is greater than equal to 9, 796 was the observations that came under this split, and out of which 136 survived, and majority, that is 82 or 83%, you can say, they died. So it is the last node here, which tells there is no further split. Then the next split was greater than 9.5. So here there were 47 observations, out of which majority people survived and 22 died. So 46% survived and 53% 46% died and 53% survived. Now the age that were greater than 19.5, there was further split. You can see here there is further split based upon sibling or spouse. So if the sibling or spouse is greater than 2.5, so the observation taken is 20. So one survived, majority died. So 95% died and only 0.05% survived. So this is how the tree has been created. So let's prune it because it is a very big data set, very big data decision tree. So to split this data, what we are doing is we will be partitioning our data into training and test data set, wherein the model will be created on training data set and will be predicting with test data set. For that, I am taking the library caret. Then there is a function within that is create data partition. So I want survived data to be partitioned. Probability, I want 80% of the data to be taken. List equal to false means the data will be in the form of matrix. If I have done true here, so the result of this partition would have been in the form of list. Then times means once. So times means how many times you want to partition the data. So I only want one partition here. So that is 80% from this survived data. So let's create this. Now what I want is in the training set, out of the whole data set, I am subsetting only the part that is the 80% that I have created here to be saved in training data set, and except that training one, all the other data should be saved in test data set. So here I have taken a minus sign to tell that ignore this data and save other data in that variable. Now checking the dimensions of both the sets that we created. So our total observations are 1309. So here you can see the training data set contains 1048 variables, the rows, and the test data set contains 261 rows. So it comes out to be 1309, totaling up our data set.